Greetings, Earthlings. Well, it's time to open this B&K curve tracer up and see what's going on. Got some screws here. It appears that someone has been in here before because there's a screw missing right there. So we'll see what that means. Let's see. I think I start with these. And yes, it is unplugged right now. So I'm not going to electrocute myself. Oh, look. When I take this off. Okay, set that aside. I see they have numbered test points in here on the PC board, which will make it easy. Those will match up with the test points on the schematic, so that'll make it easy to poke around. I don't know if we need to get to the other side of the board. Let's take this off though, just to do it. See if that, yes, okay. Ooh, look, there's the calibration controls. Electrolytic capacitor. So, performing the smell test, it smells like old electronics. I don't smell anything burned or anything, just maybe a bit of a sort of mildewy smell. Visually, I'm not seeing any signs that anything was previously replaced. Now, if something was replaced, it's not obvious. Okay. Inside here, well, this is a little weird. I don't know if you can see this in here. It's got where probably originally it had zip ties. It just has like sandwich bag twist ties, little, you know, sandwich bag twist ties. You know what they look like. That's bizarre. But again, an indication that someone's been in here. Okay, let's see. If we were to want to get to the top side of the PC board, which we probably will because we'll probably have to be replacing parts. It looks like the switches will have to, or at least these rotary switches, caps will have to come off and they'll have to be unscrewed. And then this other panel, and then the board should separate. And then we can put proper zip ties on those wires. But as long as we have it open, let's go ahead and check the power supply voltages. That's the first thing you always check. So I am going to plug it in. Let's see now. There's 120 volts over there, so I will be careful of that. You know the rule, one hand in the pocket when you're dealing with high voltages, because the current has to pass through your heart. So if one hand, if you sit on it, or if it's in your pocket, back pocket, it doesn't matter. But if it's in your pocket, then you don't have two hands for the current to pass through. Ground. This is ground. This is just connected to, this is here, and that should be ground. And then here's my test probe. Well, let's see. I see plus and minus 15 at 12, test points 12 and 16. So let's see if I can find those. Test point 12. Here's test point 12. And that should read plus 15. Okay, close enough. which is to say it's pretty much spot on. Right there. 15.14. Okay. So then test point 16, 17, 18, 14, 13, it's right here. It should be minus 15. And it is. Okay, that's good. Plus 5 is at test point 19. 19A. Huh. I guess there's multiple. Oh, and there's a 19B, I see. What? What? I wonder if it's still exhibiting the same behavior as it was. Because that logic was working, which indicated that 5 volts was okay. When we looked at it last time, it was 13. 13 is the unregulated voltage coming in. Should be 20 volts or so. 13. More than 20 volts. $24.7. Okay. And that comes into, well, test point 17 is the output of the voltage regulator. What? Which should be like 5 volts. Test point 17. That goes to the base of the pass transistor. 24.6 volts. It looks like we may have a bad voltage regulator. It's a 723. Which, of course, I don't have. Now, I did, since I was up in Mountain View, up in Silicon Valley, I did stop at Anchor Electronics, and I got some 741 op amps, because my suspicion was that this had a bad 741 op amp. But now it seems to have totally gone in the weeds. Okay, my multimeter wanted a new battery, so I replaced it. The old one says 2012, which would be, when it was expired, which means it was probably made in like 2007 or something. So, nearly a 10-year-old battery. No, more than 10 years old. So getting back to this. Oh boy. I'll just verify that it hasn't changed anything. The fact that I needed a new battery, shouldn't affect it. Test point 12, 15.09. Test point, what was it? Not 13. 16. There it is. Minus 15.06. Okay. So that's fine. 19 should be plus 5. And it's still sitting at 1 volt-ish, which is very, very bad indeed. I'm looking at the schematic. Let's look at test point 15. 4.86. That's the control That's the control voltage to the 723. So it has actually on pin 6. This is its reference voltage, 6.97. That might be a little on the low side, but it's still within spec. And then 4.86 is a little on the low side for the 5 volts out, but still within spec. That's what, 3% low. So that side of the voltage regulator is working. If we look at pin 18, this point 18, and I guess that's this one. Again, that's showing 1.18. That should be close to +5. 17 is showing over 20 volts. So here's what I fear. 17, 25. And remember, 13. This is the incoming unregulated DC voltage, 25 volts. So what it kind of looks like to me is that transistor Q4 has gone bad. Now, I think it was okay when we looked at this before, because like I said, we were seeing the TTL stuff apparently basically working. So I'm seeing what I think is this 723 basically working. The reason I say Q4 is bad is that test point 17, you see, has gone to basically up to the power supply level. It's telling that transistor, get to 5 volts, get up to 5 volts. And the transistor is just not getting it there. So that comes back into the inverting input on the 723. And so it's trying to regulate it and failing is what it looks like to me, because the transistor has gone basically high resistance. Q4, I'm not sure where that is here. It's got to be nearby 17 and 18. No, this is 17. That's the base. Well, here's a transistor right here. Okay, emitter to 18, base, and then this would be the collector coming down to 13. To 13. 13 is the 25 volts. So there's the transistor right there. And it's, what did I say? Emitter, base, collector. It does not look to have been replaced. I don't see bad solder joints. So we're going to have to take this fully apart, it looks like, to get at the top of the board and figure out what's going on. Actually, I'm curious, before we move on, if we still get the same results that we were seeing before on the oscilloscope, because it looks to me like this is an additional failure. Unexplained, because I didn't do anything to it. Let's see. This will connect me to nothing. Oh, okay. What was I looking at before? I was looking at the base. The base. Let's have a look here. And on the base, I expected, well, I had a flicky stair step. Anything at all? Yeah, no. Okay. Let's look at vertical output just to look at it. And again, pretty much nothing. And let's look at the horizontal output. Now there's something there. Okay. Well, and that makes sense because that doesn't need the, it does not need the +5. That's coming straight off of the transformer. Okay. So, yeah. That's still there. But I've got nothing now. Okay. That's driven from the +5. So, let's open it up. Okay, and so here it is opened up. Turns out this control here did not need to be removed because it doesn't mount directly to the PC board. And yes, the power is unplugged. There's that transistor, and it's right where I was saying it was. So we'll look at that. Looking at this, the latest date code I see, this was made in 1974, clearly. So the newest date code is 7419, it looks like. Well, there's a 7447. Potentially. That might be a date code. So early, 74, 75, that one has a 72 date code on it, but it's okay. They can be earlier, but it would not have been built before the last date code, unless something was replaced. And again, it doesn't look like anything was replaced on this. So in this I see right here, 741. It's got a bunch of 741 op amps. There's one. Well, I don't know why they seem to have paint on them or something. But there's one. That's the one that I was suspecting was bad. Looking at the capacitors, there's no obvious, bulging or anything, leakage from the electrolytics. They are quite old, and so it might not be a bad idea just to replace them. But this is 100 microfarads. Not sure what these are. These are in the power supply. But again, the power supply seems okay. Nothing obvious, no obviously burned chips, burns on the board or anything like that. So I think, now see, if I had a, something like, I don't know, a curve tracer, then I could pull that transistor out and check it. But I don't have a curve tracer because that's what I'm trying to fix. But as of right now, I'm suspecting that transistor. So I think I'll take it out, and I can at least test it with an ohm meter, and then see if I have a something that'll replace it. All right, well, here's the transistor removed from the circuit board, and the actual part number on this is a D40D1, even though in the manual it said it was a D40A5. Well, this has similar specs. Specs on a D40D1. VCEO, collector emitter voltage, 30 volts. which is right, about right, because we saw 25 volts there. Continuous collector current 1 amp, okay. Power dissipation 6.25 watts. I looked through my parts to see if I had a replacement. The problem with replacement parts for this is the base in the center. They don't make them that way anymore. The base is either pin 1 or pin 3. So we can only hope that this works and that that wasn't the problem. So we'll do a check here with the multimeter. I've got it in diode mode here. So if I connect this to the base, from the base to the emitter should look like a diode. Base to emitter. It's open in that direction. So if I switch it, emitter to base, well, it's also showing open. That's not good. Okay. Base to collector should look like a diode. That looks like a short circuit. The other direction looks like a short circuit. I can switch to resistance, but it's not going to make any difference. This transistor is toast. There's base emitter. Oh, well, okay. Base emitter, 112K. Okay. And in this direction, 112K. So let's see, we've got a big resistor between the base and the emitter, and we've got a dead short between the base and the collector. The 25 volts comes in on the collector. The base does nothing. Oh, collector to emitter, yeah. What's collector to emitter? Because some voltage does travel through, yeah. 111, oh, well, wait. It would be in this direction. 110K ohms. Yeah. That transistor's toast. So as I was saying, I did look. I have some transistors which are definitely higher power, higher voltage than this, but they don't have the right pin out. So I went online, and good old electronicsurplus.com actually has some of these. Now this one's made by GE, and they don't have any made by GE. They apparently did at one time, but it says sold out. But they have some made by National Semiconductor, so that'll be good enough. I ordered some, and now we'll have to wait for them to arrive for the follow-up video where we hopefully get this thing working again. Didn't happen this time.